Okay, so this problem says, on many cell phones with GPS, an approximate location can be given before the GPS signal is received. This is accomplished through a process called triangulation, which works by using the distances from two known points. Now, they don't give us a picture for this problem, so we're going to have to draw it ourselves. Suppose there are two cell phone towers within range of a cell phone. The two towers are 6,000 feet apart. Okay, so here's a tower, and here's a tower. And this distance is a straight line, 6,000 feet. Okay. It's along a straight highway running east to west, and the cell phone is north. We don't know where that cell phone is, but we'll just draw a little cell phone there. Okay, there's a cell phone. And it's north of the highway. Based on the signal delay, it can be determined that the signal is 5,050 feet from the first tower. Okay, so that distance is 5,050. And 2,420 feet from the second tower. Determine the position of the cell phone north and east of the first tower. Okay, so I'm assuming this is north, and then that's east, and so on and so forth. Okay, when they say they want to find the position, they want to know this angle right here. Okay, and then after we find that, we have to determine how far the cell phone is from the highway. Okay, so it's like two problems now. All right, so you can label these if you want to. You could call this alpha and beta and gamma, and then that means this is B, this is A, and this is C. And we're trying to find this angle alpha right there. So cosine alpha is equal to B squared plus C squared minus A squared. This is that same formula we used before, right? Over 2 times B times C. Okay, so we're going to put all the numbers in. What was my B? 6,000 squared plus C was 5,050 squared minus A, which is 2,420. Now, it makes a difference which numbers go where, you know, especially, well, the one that's being subtracted, right? Okay, so, you know, you have to be a little careful there. And then this is going to be over 2 times B times C. Okay, now, we did this before on the last one where we had to find, you know, the inverse cosine. You can do all of this calculation and then do inverse cosine. That's up to you. I'm going to stop the video so you can do this on your calculator, find alpha, and then I'll meet you back here and we'll check and see if it's right. You don't really want to hear me put this in my calculator. Okay, so I got 23.3 degrees. Now, if you had trouble with that, you know, it takes a little practice to do these on the calculator. You're going to want to put this in parentheses, and you're going to want to put this in parentheses. And then remember, to find alpha, you have to go inverse cosine of all of that. Okay? Anyway, hopefully you got the answer, 23.3. If you did, great. Yay. All right, now we got to do the second part. Determine how far it is from the highway. They mean the cell phone. How far is that? Okay, so now we have kind of a triangle. Picture it here. So we're trying to find this distance. I'll just call it H. And then we know this angle now. We know that's 23.3 degrees. And so you can just use a sine for that. So the sine of 23.3 degrees is going to equal H over the hypotenuse, 5,050. So I'm looking at this little right triangle here. And then I'm going to take 5,050 times sine 23.3 degrees. And that's going to be H. So it's going to be approximately equal to, and I will just let you hear me do this on my calculator, 50/50 sine 23.3. It's like, I don't know how accurate they want it to be. Now, it looks like they did things kind of to the nearest thousandth, so I would say it's about 2,000 feet or more accurately 1,998 feet. They might have put 2,000. What did they put? They put 1,997.5. So they went to the nearest tenth. I didn't see anything that said how accurate. I would have done the 1,998. But either way,